Hi, my name is Ryan Barton, and I'm Cody's Barton teammate for the project of the sound-based traffic control system of the project of Engineering 122 at Louisiana Tech University.
My name is Cody Martin, and my partner Ryan Barton is currently filming this, and we created the sound-based traffic control system. Our original problem is that we found that at many three-way intersections, particularly in rural areas, the way that the lights change is not entirely efficient when it comes to time allotted for each direction. So we decided that we would create our own algorithm and try to work from there. Now, a general overview is that we utilized a single sensor to detect when a car would pass by and the lights would change as such. Now, the entire scale for this model is an HO scale, which is half of the O scale developed in the early 1900s by a German toy maker named Slakov. It has hence become the most popular model trainway scale in the entire world and thus was appropriate for this model. Now, for a brief demonstration with the project. You can take one of our mini toy cars here, and as it approaches on the right side of one of our custom-made roads, it will trigger the ping sensor, which will automatically trigger our program to start effect, which changes the light to green, and the car is free to go left or right as it desires, and after an allotted time, the algorithm reverts back to normal. Now, the economic viability of this program is actually quite good, as many of the lights needed in the infrastructure are already in place. Traffic lights in and of themselves can be quite expensive, but just changing the program and implementing sensors in and of themselves is quite cheap. We did utilize the ping sensor, which is sound-based, ultrasonic-based, but we could use a variety of different sensors according to the budget we had and the quality that we wanted to go. Other alternatives include an infrared sensor to detect actual motion as it goes across, and thermal sensors to pick up heat of individual cars as they approach as well. Now, this will be relatively cheap according to how sophisticated of a sensor you get. One alternative we looked into was a much fancier ultrasonic sensor, much more than that of the ping, which ran around $100, although according to the intersection, you could use a cheaper sensor if you so desired. Now, Ryan will go into the specifics of the sketch and also our backdrop, including our mini prototypes.
All right, the sketch basically uses ping sensor like Cody said earlier. Ping sensor is a sensor that uses sound waves to interact how far the distance is. So we set it to 3, in this HO scale, we set it to 3 inches. So after 3 inches hit, it comes with the light, like I happened earlier. The lights is regular LEDs, non-LEDs, to show a 3-way intersection. For the prototypes, for our product, it don't happen overnight. It takes hours, countless hours. So for the prototype 1, we just basically scaled everything on a poster board. Prototype 2 made it more detailed, and prototype 3 we integrated 3D details. Prototype 4 is the finished prototype, is just right here. And for the scale, we basically use the if statement in engineering code we learned at Louisiana Tech University, and that's it for this code.